for part D, talking about Pascal's triangle. In problem number 2, we just need to fill in the blanks in creating Pascal's triangle. And the thing about Pascal's triangle is that every row is going to begin with a 1 and end with a 1. Then, to find every other term in there, we're going to take the two that are above it, and add them together. So on the next row, we'll begin with a 1 and end with a 1. Then start adding these two together. That'll give me a 3 here and a 3 here. Again, start with 1 and end with 1. Add each pair together all the way down the line. So 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. So let's do it again. 1, 5, 10, 10, 5, and end with 1. It's a nice little number pattern. However, there's a ton of information in there. First of all, some of the properties that that stand out with Pascal's triangle. Of course, like we said, every row began with 1 and ended with 1. So the edges of our triangle are always going to be 1. In the next number, they go 1, 2, 3, 4, 5. And they end with 1, 2, 3, 4, 5. So that second coefficient in the list is always going to be one of the counting numbers. We also notice that we have symmetry along this line, that the front half of any row is the same as the back half of any row. And these few properties are going to be very helpful for us. So when we have to expand x plus 5 to the third, we can use Pascal's triangle to help us. First of all, we have to look at that x to the third row, which is going to be the one that starts off with 1 and then 3. This is how you'll tell which row to use. This second number is always going to be the same as the power that you're using. So with Pascal's triangle, we grab that third power row, the 1, 3, 3, 1. And this is how we're going to use 3 lines of work to expand and simplify x plus 5 to the third. Now, the first step, like I said, is grabbing that 1, 3, 3, 1. And that's all we write is 1 plus 3 plus 3 plus 1. Those are going to be the coefficients in the expansion of x plus 5 to the third. Next, we're going to deal with the x. And every term is going to have an x in it. The thing is, we're going to start with x to the third because we have the third power. Then in the next term, it's going to be x squared. In the next term, it'll be x to the first. And in the last term, it'll be x to the 0. Finally, we're going to deal with the 5. And every one of these terms is going to have a 5 in it as well. And something very similar is going to happen just in reverse. Instead of starting with the third power, now we're going to end with the third power and work backwards. So the second power, the first power, and the 0 power. That's our first line of work, setting it up using the coefficients, then using the x term, and then the 5. Now it's just a matter of simplifying the expression. In this first term, 5 to the 0, that's 1. This is a 1, so this whole thing is just going to be x to the third. In the second term, 3 times 5 is 15, x squared. In the next term, I got 3 times 5 squared. So maybe we'll leave it as 3x and then just find that exponent, 5 squared being 25. Finally, in the last term, we have a 1, x to the 0 is 1, and 5 to the third is 125. Now our last line of simplifying is to see if there's any more terms that still need to be multiplied. This is the only one. So x to the third plus 15x squared plus 3 times 25 is 75x plus 125. And that's our binomial expansion. Let's do it again with one that's a little more tricky. The 2x minus 3 to the fourth power. So first of all, take a look at Pascal's triangle, and we want to get to the fourth power. This row is going to be the second power. Like we said in the last problem, this is a third power. And now we're at the fourth power. So these are going to be all the coefficients of the fourth power. because this number is a 4 and this number is a 4. So our 3 lines work. First step is just list out all those coefficients. 1 plus 4 plus 6 plus 4 plus 1. Now go through with the x's, and it's not just x this time, but it's 2x. So every one of these terms is going to have a 2x in it. And we're going to start with the power, the 4, and work our way down. So the next term will be the third power, second power, first power, and 0 power. Lastly, we're going to take the 3, but it's not just a 3. Keep that negative with it. So each one of these terms will have a negative 3 in it. And these powers are all going to work backwards. So they're going to end with negative 3 to the 4th, and to the 3rd, to the 2nd, to the 1st, and to the 0. Now our last 2 lines are just simplifying. So look at each term. Anything to the 0 is 1, and this one is 1. So we have to take 2x to the 4th, which is going to mean taking 2 to the 4th, which is 16, and x to the 4th. As we move on to the next term, most of them aren't going to simplify all in one step. So I would like it if everybody took 2 steps to do this. And how I mean that is first deal with that power 2x to the 3rd. Rewrite that as 8x to the 3rd times negative 3. Next, 6 times 2x squared is 4x, and negative 3 squared is positive 9. 4 times 2x and negative 3 to the 3rd is negative 27. And finally, we got a 1 and a 1, and negative 3 to the 4th is 81. Last step is just simplify. So simplifying each of these terms, multiplying the coefficients together where it's needed, we'll end up with 16x to the 4th minus 96x to the 3rd plus 216x squared. Looks like I forgot to put my squared there. And then minus 216x, and finally plus 81. And that's our expansion. Lastly, problems 5 and 6 speak towards the symmetry that is found inside of Pascal's triangle. Remember, with Pascal's triangle, we begin and end with 1s, and then we're going to add the 2 numbers above them to get any other one. So 1 plus 2 is 3, 2 plus 1 is 3. And what we see is we'll always have this symmetry happening. Where the front half and the back half are always going to be the same. 1, 6, 15, 20. 1. So what these 2 problems are getting at is what are the first 2 coefficients of the 13th row and the last 2 coefficients of the 30th power. Now what we need to recognize is that when we're talking about the 13th row, that's not the 13th power. And when we're looking at the 30th power, that's not the 30th row. Remember, it's this number that speaks towards the power of the binomial. So for this row, it's really the second power. Notice, this is not the second row, it's the first, second, third row. So the third row will give us the second power. The fourth row will give us the third power. The fifth row gives us the fourth power. So if I'm looking at the 13th row, that's really the 12th power. That's important for us because you notice I'm only asking about the first 2 coefficients, the first 2 numbers in any row. And those first 2 numbers that are in any row, the first one's always going to be 1, and the second one is going to be whatever the power is. So in problem 5, our first 2 coefficients are going to be 1 and 12, since we're talking about the 12th power. In problem 6, I'm trying to identify the symmetry that's in Pascal's triangle. That is to recognize that the front half of the triangle is exactly the same as the back half. So now when I'm looking at the last two coefficients of the 30th power, well, the last two coefficients are going to be the power and then 1. Power and then 1. So the last two coefficients of a binomial to the 30th power are going to be 30 and 1.